Hello, everyone. So I'll talk about air current detection in Japan. So this shows the actual situation of drowning accident of beaches of Japan. So light figure shows outbreak factor drowning accident. So you can see drowning accident happened mainly caused by rip current. So in order to avoid the natural factors, beach user can get a correct understanding of the risk awareness. So they have to carry out the risk management. However, it's a difficulty of risk recognition and judgment under the momentary change in natural phenomena. So on the other hand, swimming areas along the shore are limited. However, the number of the lifeguard is small at around 1 lifeguard compared to the thousands of beach users. So in addition, beach users sometimes enter the unpatrolled areas outside of the swimming area. So therefore, we propose a system using AI to solve these issues. So about summary of these systems, so the web cameras on the beach take photos of the surface image. Also, AI analyzes the camera's image data in real time. So at time of the occurrence of rip current, AI automatically informs it to the digital signage on the beach user, on the beach and beach user's smartphone. Furthermore, if beach user enters the rip current area, AI informs it to lifeguard wearable device. Then lifeguard can take early action. So therefore, AI has two primary functions, which are the detection of rip current and the detection of human entrance into the rip current areas. So this is a process of system development. We developed the system in 2018. So also I talked about it in WCDP 2019. So after the WCDP, the system has been applied to beaches, and the accuracy of the system has been verified. So today, I'd like to talk about the summary of first system development and the subsequent efforts. So about the summary of first systems. So at first, we collected the surface image data by 3 web cameras. Next we developed the AI models through deep learning using approximately 64,000 training data using the feature extraction from the 100 rip current annotation videos. So about AI learnings, we use analyze tools which are object detection algorithms, TinyYOLO and YOLO V3. So we verified the AI at the final point of model evaluation. The precision of the rip current detection and the human detection in the rip current area were 91% and 97% respectively. So finally, we verified the accuracy of the rip current detection by AI in trial operating of 2 weeks by 3 methods, such as a field measurement, image analysis, and numerical simulation. This shows a result of verifications. The success rate of 80% for the image analysis and 73% for numerical simulation were confirmed. So in 2019, the system was actually operated on the first study beach during summer. So we verified the function of the system after the operation. So this shows the result of the hearing survey from lifeguard. The rip current detection of 65% and human detection of 80% were mostly correct. So I'll show you an example of rip current accident during this period here. So there are two swimmers and the rip current areas here. So the rip current areas are showing an oblique angle view. So this is because the camera was set diagonally in the back of the shoreline here. Also, just now, you can see the one swimmer are drawing in the rip current area here. Here. And two lifeguards are heading for rescue him. Okay, all right. Okay, next, so I'll show you the video of the system function, which was made using a log data of GPU server here. So yellow rectangular areas means rip current area, and red rectangular area is a human detection. So AI could detect the rip current and human entrance. So sometimes AI mistakes a buoy for swimmer here. So in this, also system was able to inform the digital signage and the lifeguard smartphone. So in this case, lifeguard could take early action by the system. The life of the swimmer was saved by approximately by 50 seconds. So then, we confirmed that AI function are generally good. So in 2019, we applied the first system at the second beach. This shows the number of rip current detection in 2019. So you can see the AI detected the rip current only 3 days. So like this. So then, the first AI model could barely detect the rip current. So then, we developed the system for second study beach using the same method as the first. So this shows the example of rip current detection by second AI model here. So at the final point of the model evaluation, the ratio of recall was 69%. Okay. So in addition, we added the new function which can inform the alert under the offshore wind condition. So this is because the offshore wind is a second outbreak factors of drowning accident. So this shows a comparison of alert and observed offshore wind. So they are in good agreement here. And in 2020, we verified operated systems at first study beach. The number of rip current alert was 1,835. Also, the rescue request was 507. So I think the system has contributed the prevention of rip current accident for 1,839 people. So at the second study beach, we got a similar result as like this here. So in 2020, we developed the system for the third beach. So World Masters Games Lifesaving Competition will be held on this beach in 2022. So if you will visit this competition, please check it. So also now, we currently verifying the systems. Yes, so I'd like to conclude my presentation. The system was generally good and actually contributed to the drowning prevention for many beach users. However, the AI model for detecting rip currents should be created on individual beaches. So it's not a general purpose technology yet. So I think this issue can be solved by being applied to many beaches. Yes, that's all. Thank you for your attention.